Alright, today's lesson is on inequalities in triangles. We're going to talk about inequalities in single triangles, and then we're going to talk about inequalities in more than one triangle. So here we go. First thing we're going to talk about is comparison property of inequality. Basically it says if A is equal to B plus C and C is greater than 0, then A is greater than B. In other words, if you have to add something to B to get A, which is a positive number, then of course A must be bigger than C. Alright, our next thing is the corollary to the triangle exterior angle theorem. If an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles. This makes sense because we already know that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Right? So therefore, angle 1 and angle 2 are measures. They're greater than 0. So then the measure of angle 4 is going to be greater than the measure of angle 1. So measure of angle 4 is greater than the measure of angle 1. And the measure of angle 4 is greater than the measure of angle 2. Alright, so this is a corollary to the triangle exterior angle theorem, which says the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Next thing we're going to learn is how do we apply this corollary. Alright, we're looking at the figure at right. We have the measure of angle 5 is greater than the measure of angle C. What's our justification for each statement? Angle 5 is an exterior angle of ADC. So we're looking at this triangle right here, ADC. Here's 5. It's an exterior angle, so that's just the definition of exterior angle. So we know that 5 is equal to 3 plus angle C. And so the corollary of the triangle exterior angle theorem says that the measure of angle 5 is going to be greater than the measure of angle C right here. Alright, if theorem 510 basically says if one side of a triangle is longer than the another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So in our drawing here in triangle that we have, segment QR right here appears to be longer than segment PR. So therefore, this angle, angle P, is greater than, so angle P is greater than angle Q. It deals with the sides opposite. So this side's opposite P, this side is opposite Q. Excuse me, this side is opposite P, and this side is opposite Q. Again, as we're going over these theorems, you have them there in your notes. Just follow along. If there's anything you have to do after a theorem, just go ahead and write it down and do that work. Hit pause if you have to, and then continue the video. Our next, we're on about theorem 511. If one angle of a triangle has a greater measure than another angle, so in this picture here, we're going to say that angle P, right there, angle P is greater than angle Q, so therefore the side opposite RQ is greater than PR. Alright, so if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So angle P is greater than angle Q, then RQ is greater than PR. Finally, looking at theorem 511, in the figure at right, the measure of angle S is 24. So this measure right here is 24. And the measure of O is 130, so that's 130. Which side of triangle SOX is the shortest side? So first thing we use the triangle angle sum theorem. We say the measure of angle X equals 180 minus the measure of angle S minus the measure of angle O. So 180 minus 24 minus 130 equals 26. So if I look at my little table below, angle O, I've discovered that it does not like my objects that I inserted in here, so I've got to figure that out, is 130 and its opposite side is SX. Alright, angle X is 26 and its opposite side is OS. And finally, angle S is 24 and its opposite side is OX. So obviously the shortest side is the one opposite 24, which is segment OX. And the smallest, and its opposite the smallest angle, which is S. Alright, so let's continue on to the next slide. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. It makes sense. So let's look at this a little bit closer. If I take AB and I add it to BC, that sum is greater than this distance here at AC. If I take BC and add it to AC, then that's greater than this distance here. And finally, AC and AB is going to be greater than BC. It's common sense. If a triangle does not satisfy the triangle inequality theorem, well, let me rephrase that. If three sides do not satisfy the triangle inequality theorem, then it's not a triangle. As simple as that. So using the triangle inequality theorem, can a triangle have sides with lengths 2 meters, 6 meters, and 9 meters? So the first thing we do is the sum of the lengths of any two sides must be greater than the length of the third side. So I need to write the three sums and the three inequalities. 2 plus 6 is 8, 6 plus 9 is 15, 2 plus 9 is 11. So now I want to do the math. And as you can see right here, 8 is less than 9. So one of the sums is not greater than the length of the third side, so it is not possible for a triangle to have sides with lengths 2, 6, and 9. And that's how you use the triangle inequality theorem. It's real simple, not a big deal. Alright, finding possible side lengths. A triangle has side lengths of 4 inches and 7 inches. What is the range of possible lengths for the third side? So the first thing is we let x equal the length of the third side, and we use the triangle inequality theorem to write and solve three inequalities. So x plus 4 must be greater than 7, x plus 7 must be greater than 4, 7 plus 4 must be greater than x. When I do the math, I subtract 4 from both sides, I get x greater than 3. I do the math again, I get x greater than negative 3. And then the last one, I get x is less than 11. Now, underline the correct word to complete each sentence. Length is always, underline, always positive. The second inequality pair is invalid in this situation. So while the remaining inequalities so we write the remaining inequalities as a compound inequality. So x is greater than 3, so 3 is less than x, which is less than 11. The third side must be longer than 3 inches and shorter than 11 inches. And that's how you determine the length or possible side lengths of the third side of a triangle once you're given two other side lengths. So you set up the inequalities, you solve the inequalities, you write the compound inequality that tells you how long and how short the other side must be. Alright, this is when we're dealing with two triangles and inequalities. The side angle side inequality theorem, or the hinge theorem, says, let me get this so we can read it all. If two sides of a triangle are congruent, to two sides of another triangle, and the included angle in one triangle has a greater measure than the included angle in the other triangle, then the third side of the first triangle is longer than the third side of the second triangle. Now, I'm missing all my information here, and we'll go over that tomorrow just to double check it. But for right now, what you need to realize is, assuming that two sides of a triangle are congruent. So say AB is congruent to PQ and AC is congruent to PR. Since angle 1 is bigger than angle 2, BC, the distance between BC is greater than the distance of QR. That's what it's saying in a nutshell. It's called the hinge theorem because if you think of a hinge on a swinging gate, so the angle is swinging from a large angle to a smaller angle, and it shortens the third side. All right, let's look at the converse to the hinge theorem, the SSS, or side-side-side inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, and the third side in one triangle is longer than the third side in the other, then the angle between the pair of congruent sides in the first triangle is greater than the corresponding angle in the second triangle. So here we go. Two sides of a triangle are congruent to the two sides of another triangle, and the third side of one side is longer than the third side. So again, AB is congruent to PQ, AC is congruent to PR, and BC is greater than QR. Therefore, angle 1, the measure of angle 1 is greater than the measure of angle 2. So let's use the triangles at right to complete the table. 513, the hinge theorem, the measure of angle A is greater than the measure of angle X, and BC is greater than YZ. The converse of the hinge theorem, if BC is greater than YZ, then the measure of angle A is greater than the measure of angle X. Alright, so what I want you to do, part of your homework assignment tonight, besides watching the video, is explain why theorems 513 and 514 are also called the SAS and the SSS inequality theorems. Alright, using the hinge theorem, what inequality relates LN, which is this distance here, and OQ in the figure at right? Okay, excuse me. Use the information in the diagram to complete each statement. The included angle in triangle LMN is angle M, and the included angle in triangle OPQ is angle P. Circle the side opposite the included angle in triangle LMN, so the side opposite is LN, and underline the side opposite the included angle in OPQ. Here's P, so it's OQ, or QO, so we're going to underline that. So use the hinge theory to complete the statement below. The measure of angle M is greater than the measure of angle P, so LN is greater than QO. And that's how you use the hinge theorem. Very simple. Alright, using the converse of the hinge theorem, what is the range of possible values for x in the figure at right? So from the diagram, you know that the triangles have two pairs of congruent corresponding sides. That LM is less than OP, or PO, however you want to say it, and that the measure of angle N equals 90. Alright, now the measure of angle K is less than, let me make sure I get my right sides here, we're talking about LM, so it's K is less than measure of angle N. So 3x plus 18 is less than 90. We're going to subtract 18 from each side, and I get 72. So we subtract 18 from each side. And then I divide by 3, and I get 2, 4. Divide each side by 3. So the measure of angle K is less or greater than 24. Excuse me, the measure of an angle of a triangle is greater than 0. Measure of angle K is greater than 0. So I say 3x plus 18 is greater than 0. So I'm going to subtract 18 from both sides. Alright, here we go. I had a senior moment there for a second. We're going to substitute 0, and we basically keep 3x plus 18 is greater than 0. So 3x is greater than negative 18. I forgot we're solving for x, so we're going to subtract 18 from both sides. And I get x is greater than negative 6. Divide each side by 3. So that's not a problem here because I'm solving for x. So I'm going to write the inequalities as a compound inequality. I'm going to put them together to find the measure of angle K, or for the value of x, which I will put in to find the measure of angle K. And I get that negative 6 is less than x, which is less than 24. So the value of x can be between negative 6 and 24. Sorry about that. Senior moment. I'm going to divide where I want to do this or not. Alright, here we go. Proving relationships in triangles. Given that the measure of MON equals 80, and 0, O is the midpoint of LN, prove that LM, this distance here, is greater than MN, this distance here. So that's what we're trying to prove. Alright, first thing I know is that the measure of angle MON is 80, that's given. Also know that the measure of angle MON plus the measure of MOL equals 180, because those are supplementary angles. So 80 plus the measure of MOL equals 180, and that's just substitution. And finally, the measure of angle MOL is 100, that's subtraction property. Alright, I know that LO is congruent to ON because O is the midpoint, that's given to me. Of LN. And I know that MO is congruent to MO, which is a reflexive property. So I can say that the measure of MOL is greater than the measure of MON, because last time I checked, 100 is greater than 80. So finally I can say that LM is greater than MN by the hinge theorem. So that's how we prove relationships in triangles using the hinge theorem. Alright, so that's my video. That's the way I'm going to do it. Start working on trying to do it. I'm sorry it might be too long. I hope you have a good evening. Go Michigan or Louisville. Whoever wins, I'm going to go to sleep, so I don't care. I will see you in the morning where we will talk more about triangle inequalities. Hope y'all had a good night.